Hi, everybody. Thank you for coming back from lunch. How was it? So I'm Francis Campoy. I'm a developer advocate working for the cloud team. And in this part of the talk, we're going to build your app, the app Abelana, that I think all of you heard before during the first talk of this track with Wes. So we're going to build it now. We're going to build the first step. We're going to actually build an app that is not going to be good enough. And then we're going to just improve it. But we're going to start building a very basic app. So what is Abelana? It's an Android app. Abelana, by the way, means to share in Zulu, if someone's curious about it. And you can download it right now if you want to. So you can play with it while I'm talking, but keep on paying attention to me. Thanks. So basically what you can do with the app is you can take pictures, share those pictures with your friends, and then you can like your friends' pictures, put some comments on it, or anything you want to do. So it's going to stay on the side for a little bit. From a more technical point of view, what Abelana is an Android app with a backend on the cloud. And what it's able to do is it's able to allow multiple authentication providers. So you can sign in with a Google account, but also you can use Facebook or Yahoo or Twitter. I don't remember all of them that we did. But if you haven't heard about the Google Identity Toolkit, and you want to have a lot of ways to sign into a given app, you should check that out. I don't have time to speak about that today, but you should definitely check that out. Also, we're going to talk a little bit about image formats, and we're going to be talking about WebP. How many of you know what WebP is? That's the whole room, just for the video. So WebP is a format done for the web, and we'll discuss a little bit what it is a little bit later. And the main goal of this app is for us to help you learn how to use the cloud. So the main goal is this is something that is easy to build. This is a pedagogical example. We want you to be able to understand everything that is going on, and then go home and do it yourselves. But at the same time, we're running on the Google Cloud Platform, so it's something that's going to be both scalable and really fast. So enough chatting. Let's do some code. So we're going to start with the basic solution. And the basic solution is going to be really simple. We're just going to have this data, not all the data, so no comments, no likes, just the basic data. For the users, we're going to have an identifier. It's going to be a unique ID that identifies our users. It's provided by the Google Identity Toolkit. There's also the name of the user and an email. And then for the pictures, we have also an identifier. We have the author or the user ID of the user that took the picture, the date where the picture was taken, and finally, the image blob. And the image blob is something that could be pretty big. It could be around some megs, probably, depending on what you're uploading. So we will store most of it in the data store. So it's basically data that we're going to be storing in the data store, the non-relational database that you can use on the cloud. But the image blobs, they're too large. So rather than storing them in the data store, we'll store them on cloud storage, which means that our app will be able to upload and download directly files from the cloud storage, making our app even simpler. How many of you know Go? Cool. That's not many people. We're going to be writing this in Go. So you're going to have fun. Go is really simple to learn, so don't worry about that. I'm sure you're going to understand every single line of code that I'm going to be writing. And also, Second Advantage has a very cute mascot. And it's going to be running on App Engine, of course, the first version. Then we'll iterate and we'll improve our architecture. OK, so this is the architecture we have so far. We have our Abelana app. We'll take a picture, and we'll name it with this schema. It's first the user ID, which is provided by the app itself. Then it will generate a picture ID, and then an extension, which could be BMP or JPEG or GIF or GIF, depending what you pronounce. And that picture will be uploaded directly to cloud storage. Now, when that picture is uploaded to cloud storage, we could ask the app to then send a new request saying, hey, the app, there's a new image now. You should tell the server that there's a new image, and you should process it. But there's a different way of doing it that, in my opinion, is even better, which is bucket notifications. So basically, you can tell cloud storage to watch a bucket. And every single time there's a new element in that bucket, so there's a new file in that folder, to send a notification to somewhere. And that notification, we're going to be sending it. So that notification that I'm representing it with that little link there, that's going to be sent to the Abelana server running on App Engine. Now, we're going to be able to decode that notification and process it. Now, when we process it, we'll store it in the data store, so we can remember it, all the images that we have and serve them later to our app. OK, so let's do some code. OK, so the first thing that I'm going to do before, actually, let's go. This is what I'm going to do today. The first thing that I'm going to do is I'm going to create a new cloud bucket, a cloud storage bucket. To do that, we just need to go. Let's make this a little bit bigger. There you go. We can go to, on the bottom here, there's storage and storage browser. And I want to create a new bucket that I'm going to call Abelana GCP in, because the input bucket. But we're going to put all the pictures starting there. I created, done. Now we have a bucket. Now what I want to do is I want to set a notification every single time that there's a new file. I want a notification to be sent to my server. And to do that, I'm going to use gsutil. So gsutil has a command called notification that allows you to add notifications when you want something on your bucket to be notified. I'm going to say I want to watch the bucket. Now, the next step, so by the way, that failed. There you go. So the next command is the URL that will receive the notification every single time there's a new file. And that's going to be a URL that belongs to our app. So when you deploy anything on App Engine, you get your project ID .appspot.com. So that will be HTTPS Abelana GCP, which is the ID of my app, .appspot.com. And then some path. In this case, I'm going to call it notice Abelana GCP in. And last, you say, what's the bucket that you want to watch? So in this case, we named it Abelana GCP in. Now I run this, and if everything goes OK, there you go. So now we have a notification channel that has been created. So every single time that there's a new file uploaded to that bucket, we'll receive a notification in that URL. Now, what's in that URL? Well, so far, nothing. So let's do that now. Let's deploy an app that will handle those notifications. The first step that we need is we need an app.yaml. Basically, app.yaml will define and describe what your app is. And our app is, we need to give a version, which have the first version, so 1 works. The runtime is Go, and then the handlers, it says basically it does routing across all the requests that you get. We're just going to handle everything with the Go app. So we say Go app, which is a special keyword that will call our Go binary. And now let's write some Go code. So in Go, everything belongs to a package. So we start with package something. I'm going to call it basic. Now, what I will do is I will say in the init function that it's run right at the beginning of the program, before main, I will say, oh, if there's a request going to Abelana GCP in, execute this function. So that's handle function for notice Abelana GCP in. Handle it with, I'm going to call it notification handler. Cool. And now I need notification handler, which is a function that will be executed every single time. And for now, what I'm going to do is I'm just going to log whatever I receive. I don't know exactly what I'm getting, so I'm just going to log it. To log, the first thing that you need is an App Engine context. An App Engine context is created from a request. This is actually very useful because you given a request, you can see all the requests that you're sending, all the logs. If you're calling the data store or remote servers, everything is linked via this context here. We're going to need an App Engine here. There you go. That's wrong. There you go. And what I'm going to do is I'm just going to log whatever I get from the request. So I can do read everything from the body of the request. That will give me a body. And an error is something goes wrong. If an error goes wrong, something goes wrong, so the error is not nil, what I want to do is I want to log it. This is something serious, something bad happened. So what I'm going to do is I'm going to first create an error page. And the error page, I'm going to avoid giving too many details to the user, so I'm just going to say, oops. You could also print something cool like GitHub does, that 404, something like that. You can write whatever you want. And the code is going to be internal server error, which is 500. I'm going to log it. So it's like, oh, read all fail, and this is the error, and I'm going to exit. Otherwise, if everything went fine, I'm just going to log in the info app, the request was this. Cool. So now the next step is, does this compile? That's an important step. To do that, you have two options. One option is you deploy. And if it fails to deploy, well, you didn't compile. That's an option. But there's another option, which is using, here. So you can do gcloud preview for now. That will be removed very soon. Preview app, run. So now I'm running my app locally. This will start a server, and it will start the server in localhost 8080. We can go check it, and gets 404, not found. Why? Because we're not handling that one, but we're handling notice, Abelana, GCP, in. And with this one, we get nothing, because we didn't print anything, and that's OK. But if we check the logs, you will see that in the info, there's a request that doesn't have anything, because a GET request doesn't have a body. So we log NP. But this looks pretty good, so let's deploy it. To deploy, the only thing that I have to do is replace deploy. I run with deploy. That's it. Now my code is being sent to the production servers of App Engine. It's being compiled. It's actually faster than me. It was compiled, deployed, and everything was successful. And now it's checking that the new version is actually running. And it checked, so everything worked. Cool. So now what we're going to do is we're going to upload a file to the bucket. That file will generate a notification that will be sent to our Abelana server. And the notification will be just logged into the info logs. Let's try that. So I'm going to upload a file. I'm going to upload a gopher. Don't I have? Oh, yeah. A gopher. And I'm going to load it to Abelana GCP in. I'm done. Now this generated some notification that was sent to our app. So if we go to the developer console, we have this monitoring part, and we can check our logs. And the last log, there's all of them because this is not the first time I do this demo, actually. I rehearsed. But you can see, there you go. You can see that we printed this thing. And contains a lot of data. It's a JSON file. But the only thing we care about is actually the name of the file. Everything else, not really important for our case. So we want to decode just the name, which is frances.gopher.png. OK, so how do we do it in Go? How do we decode JSON code? It's actually really easy. When you use a JSON decoder, so JSON.new decoder, and that will read from a reader, from anything that you can read from. And the request body is one of those. So we can read. We're just going to decode stuff from the body of the request. And we're going to decode into something. And what is that something? Well, it's a struct that declares what we care about. So we don't need to decode the whole JSON file, which is we're going to choose to decode only the name. So we can do that. I'm going to name it data. And name is a string. And in JSON, it's actually named with lowercase. So I have to write that thing. Now, when you decode JSON from the wild, the probability of it failing is pretty high. And if it fails, it's not an internal server error. It's just bad data arriving to your server. That happens. So when you decode, that returns an error. If this error is not nil, what I'm going to say is like, OK, this is not good. I'm not going to log it. I'm just going to say invalid notification. And the status will be, this is not bad gateway, bad request. And I will return. Otherwise, just print the name for now. Cool. So, oh, I did the wrong thing. So we're going to deploy it again. Now, while we're deploying it, so the next step that we're going to try to do is we're going to try to now store that name into the data store. Because right now, we're just logging it. That's not enough. We actually want to store it somewhere. So, but first, let's check if that worked. So let's upload the file again. Go to our logs. And the last log says, there you go. The request now, it contains only the name. We actually decoded the part that we care. Cool. So let's store something in the data store. And to store something in the data store, we have to define what we're storing. In this case, that will be a type. So we're going to create the type image. So I'm going to define it here. So the type image is a struct that has an ID, so the image ID, user ID, which is a string. I'm going to call it taken, which is when the picture was taken, which is a time. And finally, that's enough. Yeah, that's enough. So now we save it. And we're going to use, so I'm going to split our name by the little columns. So the first part is the user ID. The second part is the picture ID. I'm going to call that TS for pieces. So user ID and image ID are PS of 0 and PS of 1. Cool. So now I'm going to create an image, which is an image with ID, image ID, user ID, user ID. Oh, that's wrong there. And taken is now. And finally, we're going to store that into a data store. To store something in the data store, we use datastore.put. And that takes 3 arguments. The first one is a context. Again, everything that you do from App Engine towards a service will always have a context. The next step is we need a key. So I'm just going to call it key for now. And then the image itself. Now, what is the key? Well, the key is something that identifies uniquely this image. Well, we have the image ID. So we're going to create an image, a key from the image ID. To do that, it's datastore.newKey. Again, a context. And the next step is the kind. So the kind, if you remember from West Talk, the kind is the equivalent for non-relational databases to what we could have as a table in a relational database. So I'm going to call that image. The next step is the image, so the ID string. You can choose between using a string or an integer. We're going to use an integer and a string here. It's going to be the image ID. The integer, if we say 0, is like, oh, no, we're actually using just the string, so 0 here. We don't care. And finally, what's a parent? We don't have any parent here. So you could have hierarchies of keys if you want to. We don't have that in this case. OK, so now when we do datastore.put, again, as everything that you do on the cloud could fail. So you have to handle it. So that returns 2 values, but I'm just going to get the second one. The first one is a new key, and we don't really care about that one. Now, if something fails, we're going to say that, oh, yeah, now this is actually serious. So we're going to log it. So datastore.put fail with an error. And we're going to also fail. We're going to say, again, we're just going to say, whoops, and an internal server error. Cool. So when I'm deploying, let's see the code again. So now what I'm doing is I'm decoding the notification, the JSON notification. I'm getting that. I'm separating the name into pieces. I'm getting the user ID, the image ID, putting that into the data store. And that failed because it didn't compile, because this is wrong. I know why. OK. Let's assume you didn't see that. And now it compiles. Cool? Yeah. Ooh, one file left. Yeah, OK, cool. So now it actually compiled. Good. So now once this is deployed, what we're going to do is we're going to upload again a file to the bucket. And what we're going to see is that, again, it's going to happen the same thing. A notification is going to be sent to our server. Our server will decode the notification and store a new image into the data store. And how can we make sure, how can we be sure that this actually worked? Well, there's the logs. But it turns out that I'm not logging that much anymore, so I'm not logging anything. It didn't fail. That's everything we know. But we can actually go and check the data store. So if we go to the storage, cloud data store, we can do a query. And we can see that there's an image, for kind image, there's a value with key Gopher, and the ID of the image is Gopher. It was taken, this is the time UTC, so 8 hours, London, and user ID, which is me, Francesc. Cool. So now the last part that we need is we need to be able to just serve that we want a REST API, which is basically just serving JSON. So what I'm going to do is I'm going to serve the list of all the images that we have so far as a JSON object. OK, so to do that, that's a new entry point. So I'm going to say handle.func. Let's call it images. And let's list images. So let's go to the bottom. Actually, no. Let's do it here. So a list images. It's going to do a query into the data store. To that, turns out we have datastore.newQuery. So we can do datastore.newQuery. And when you do a query on a kind. So in this case, again, the table that we had before, which we named image. And we could order it and say, actually, order it backwards in time. So I want to see first the picture that's the newest one. And then get all the pictures, get all the images. And to get all, as everything gets first a context. So we need a context, by the way. Append new context of R. And then a list of images. And the list of images is just going to be, that's a slice of images, basically a list of images. And that will return again an error if something goes wrong. If that error is not nil, what we'll do is, again, say, whoops, and internal server error. So normally when you do an actual app, you just put all the error handling together. You don't get to write this over and over. But for a little demo, this is OK. And I'm going to log also data store query fail, and this is the error, and exit. And otherwise, I'm just going to encode the list into JSON objects. So I'm going to create a new encoder. I need a writer. Well, the first argument that we get, it's a response writer. And you can write into it. You can write the response into it. And just going to encode it. And we're going to encode our images. And that's it. Now everything is done. Let's try it. Let's deploy it. And I'm going to upload a second image to see that the list can have more than one element. Otherwise, it's not really a good demo. Let's see. Cool. Let's call it something different. Cool. And now, if we go here, we'll see that we have now 2 images. And if we go to abelanagcp.appspot.com/images, whoops. So that's bad. Let's see what happened. So we can go back to the logs. What is the logs? Right here. Monitoring, logs. Let's see the last one. Actually, I think I know what happened. Yeah, no. This is a pointer. Yeah, So you can check, you see the error is different color, and it says, oh, what you passed is not a good entity. So let's try that again. Let's deploy it again. And everything should work fine this time. So we go back here. Oh. There you go. So now we have a list in JSON that we can consume very easily from the Android app. Cool. So let's go back to the demo. So now, this is not the best app in the world. It's pretty simplistic. And I have a little disclaimer for you. I'm not going to write all the code today. I know. This could be a pretty long experience. I think that Les and Zafir were sitting somewhere there. We spent, I think, 2 weeks writing this app. But all the code is going to be open source. So you can go through the whole code. It's already open source, by the way. I guess that in the next talk, we will have a link to that. OK, so the first thing that I want to improve is, what do I have to do now if I want to serve the data, the timeline, so all the images that I should see? Well, the flow right now is I have to get, given the user ID, I have to go to a data store and get the list of the users that user follows. And then for every single one of those users, find all the latest pictures and merge everything together and send it back through JSON. Turns out that imagine people following thousands of people, users following thousands of different users that take thousands of pictures. All of a sudden, you end up with a lot of things that you have to do. So my first reaction when I think about something that it's a pretty expensive computation and that I want to do pretty often is caching. But turns out that if you do caching here, you used to have a problem, now you have two. Because now you have to think, when do I have to invalidate this cache? And you have to invalidate it every single time that a user uploads any picture. So actually computing that is already hard. But especially once you invalidate the cache, you have to compute it from scratch. So that's not the solution that we want. Instead, what we want to do is to do the work as early as we can. So when we're actually serving the timeline, everything is ready for us. So what we're going to do is every single time there's a new picture, we're going to, as before, put that picture into the data store. But at the same time, we're going to have this idea of the timeline, which is materialized as a list of picture IDs. And we're going to go through all the users following this user. And we're going to append that picture there to the list. It's going to say, hey, there's a new picture there. And then when we want to retrieve the timeline, we just get the list and send it back. That's it. So to do that, we chose to do it with Redis. Why? Because we could do it with the data store, by the way. But if you do it with the data store, you could have a field, which is a list of images. You could have to retrieve that, add one, and send it back. So there's this idea of actually having to retrieve and send the whole list every single time. But especially the problem would be that you could need to do that in a transaction, because otherwise 2 people could try to get the list at the same time, add a new picture, and then which one wins? Well, you don't know, but you might lose some data there. Redis, though, on the other hand, is able to handle lists and has operations that are atomic, like push. Lpush will push a new ID onto the list directly. So you don't have to manage any notification, any transactions in this case. So this is a very good solution. Now, how do we run Redis? Well, running Redis on Compute Engine turns out to be really easy. So you go back to, that's not the good one. Oh, there. If we go back here, we'll see that there's, on Compute, there's App Engine, Compute Engine, Container Engine since this morning. I hadn't seen that before. And click to deploy. And when you have click to deploy, you have this list of technologies that you can deploy just in one click. Actually, 2. So you have to click on go first and then on deploy. So there's 2 clicks, not 1. You can choose how many servers you want to run. In our case, with even 1 could be enough. We're just deploying our app to make sure that everything works. In deploying the next talk, you will see more about how many servers you want to deploy, how to manage them, and so on. So now we click on Deploy Redis. And this might take from 3 to 10 minutes. So in the meanwhile, let's see. So now our process is we get an image, we get the notification that is sent to the Abelana server, and the Abelana server will do two things. It will send it both to the data store as before, but also to the timelines, and the timelines are only on Redis. So let's see if this is already working. Still deploying. So basically now our code is going to look like this. The first thing we're going to do is we will find the user in the data store, and that will return the user and an error. In Go, you have to manage errors, which means that by the end, you end up having an app that is very robust. All the errors are managed. We will create a new connection to our Redis instance, and we will do push, lpush. So lpush is this operation where we're going to add the photo ID to the beginning of the list of images that the user should see, user F, which is in the follows me list. Now, on the other side, serving a timeline, it's just simply going through that list. And to do that, you can do lrange. It's an operation that will just return the whole list of elements that you should show. In here, we're going from the beginning to the end, so from 0 to -1. But you could very easily change that and do from 0 to 100 or 0 to 10 and do pagination with that. Let's see if this works. There you go. So now our Redis instance is deployed. And we can see all the instances running here. Oh, no, not App Engine. Compute Engine. VM instances. Cool. So you can see the 3 instances have been deployed. You can already log into them, and you have the IPs that you can use to connect to the masters and so on. I will now explain more about that. So what I will do is I will go back to Redis and say, you know what? I'm done with this cluster. Just delete it. And that's everything you have to do. Everything that was installed will be uninstalled directly. The second problem that we have with our app is the image formats are not handled at all, which has different problems. First of all, we want to serve only square images because they're beautiful. And we need to crop the images that we upload. We also want to serve different quality of images for different devices. So if I'm using Abelana with an Nexus 10, or if I'm using Abelana with a watch, I don't need the same image quality at all. And sending a huge image to the watch is wasting bandwidth, and sending small images to the Nexus 10 is a bad experience for the user. So we want to have good experience for the user. And finally, we want to make sure that we use the bandwidth, we really use the bandwidth as we should. So serving BMPs, bitmaps, is probably not a very good idea. So this is a gopher again. So what we're going to do is, given a gopher, we've given an image that is not square. We're going to crop it to look square, to be square. And we're going to generate a bunch of images, different sizes, and so on. To do that, we're going to using ImageMagick. How many of you know what ImageMagick is? Cool. It's a very well-known open source library. It's an awesome library. And it provides you with capabilities to crop images, resize them, and anything that you could imagine with images. And it also accepts plugins. So you can encode things to whatever format you want as long as you install a plugin. You can use it as a command tool. It's called Convert. Or you can also use it with a library. I'm using a Go binding library. It turns out to be really easy to write. The code, again, is online. I won't show the code for this, but everything is online. Now, the problem is that it's written in C++. And you cannot install C++ on App Engine. So what do we have to do? Well, we will run it on Computer Engine. Then we're also going to use WebP. And WebP is a format that was created for the web. It's an image format specifically created for the web. And it has the same capabilities as JPEG of lossy compression and PNG of lossless compression. You can compress an image without losing any precision. But at the same time, it also supports transparency. And the most important part is that the size is at least 25% smaller than JPEG or PNG. So if you have to serve images, this is the good thing to do. And pretty much, I think that every single device these days supports WebP. So OK, so how do we get ImageMagick and WebP running everything on Compute Engine. So let's go back to our, actually, I'm going to go back here. I don't want to get lost. So we go back to our VM instances, and we're going to create a new instance. When we create a new instance, we get to this form, and you have to give it a name. So I'm going to call it ImageMagick 1. And I will show the advanced options that I will use later. This is going to be a web server, actually. So every single time that there's a new image, the notification will be sent to our server. So I'm going to allow them to be an HTTP server to open the port 8080. In this case, I changed it. For the rest, you choose the zone where you want to run it. So let's run it in US Central 1A, for instance. And you get to choose the machine type. There's some really, really powerful machines. I don't need to have a very powerful machine, especially because I'm just testing and just writing my code at this point. So the standard one should be OK. And now, so the boot disk is going to be a new disk, so a solid disk, a local disk, that's going to be running a Debian image. At the end, I will delete that. I wanted to have a static image, a static IP, because I want to be able to always use the same IP from my system. So I want to have the same external IP all the time. So I'm going to call it ImageMagick-IP. I'm going to create it. And that should be pretty fast. There you go. So now we have a new IP. And finally, I'm going to configure a service account. Service account is used to help our instance authenticate with other services. So in this case, our service account will be, our instance will be doing three things. One is download images from the buckets, the images that it will reformat. Then upload images to a different bucket. And also, we'll send notifications to all the services. And for that, we will use the user info, so we can check that that's the token that we think it is. So I will use user info, and then for storage, read and write. Now I click on create, and this should be also pretty fast. So we're creating a new disk from the image, from the Debian image that I chose. We're deploying a new VM instance, and there you go. You have it running there. And you can check what we have inside. So far, we don't have data because we just created it. But you could see the performance and how much this machine has been used over time. This is an HTTP server, the IP that we're using, so on. And then the user info is enabled, and the storage is read-write. Cool. So now I would like to log in into it. So for that, you just click on SSH. And that will open an SSH window for you. This should take 2 or 3 seconds. Oh, there you go. Cool. And once you're in here, you can do whatever you want with this machine. This is your machine. You can install, do sudo apt-get, whatever you want to do. What I want to do is install all of those tools, WebP, there you go, WebP and ImageMagick, and then also install Go, and then get my source code and start everything and run it. So you can see a little bit here. Basically, everything that I'm doing is the typical Linux commands that you could expect, wget to get new software and then install it, and so on. So I'm just going to run it. And then, so I have 11 minutes left, and this is around 15 minutes, so we're good. Now, this takes a long time, and that's OK. But the thing is that, you know, the cooking shows when you put something in an oven and then you take it out from the different one? So we're going to do that. But the cool thing is that you can also do that. So let's see. Turns out that when I had an instance that went through that project, that bash script, and installed all the tools that I wanted. And at the end, what I did, I created a snapshot out of the disk. So now it turns out that I can create a new image, a new instance, sorry. And when I create the new instance, so ImageMagick 2, I'm going to say exactly the same thing as before. There's going to be something slightly different. Central A. which is rather than creating it from an image, I'm going to create it from a snapshot. And I'm going to choose the image magic snapshot, which I prepared before. That's the other turkey. And for the rest, I'm going to use exactly the same thing. So user info is activated and read write for storage. Now I'm going to create it. And now when we're creating, the instance is pretty much the same thing. But now our disk will contain everything that we wanted. So now once I log in, I will be able to run convert. And that could be the proof that everything is running. Actually, it could even run my server, the Abelana image formatter server. So of course, now it's when it's really slow because demos. There you go. Cool. So now I can check this out. And it's the same kind of image. It's the same kind of machine. It's also, again, an HTTP server. And it has the same services the same permissions that we had before. So everything is exactly the same as before, except for the disk. And now let's try to connect to it. Now when I connect to it, let's see, in 3, there you go, even faster. So now I can actually go, I have everything ready already here, so I can run my ImageMagick server. And my ImageMagick server is running, so everything has been installed. Which means that actually deploying this in production turns out to be really easy. So now what we're doing is this. So the ImageMagick server will receive an image. We'll generate a bunch of them, new ones. We'll send them to the new bucket that I haven't defined here, but basically we have 2 different buckets, input bucket and output bucket. Then we will prepare a notification from our compute engine instance, and we'll send it to the Abelana server. And then the rest will be exactly the same. So with Redis or not, it's pretty much the same flow. We already built it. OK, so for the last part, I wanted to talk about scalability. So when we see this architecture, the part in the middle, it's incredibly scalable. Why? Because you don't have to manage that. It will just scale for you. We're using just App Engine that will scale very well for you. We're using cloud storage, and we're using data store. Those products have been designed with scalability in mind. So no problem in that side. On the other side, though, we have one instance of our server. So if we all of a sudden, I let you all upload pictures, and we get like hundreds or maybe like millions of pictures at the same time uploading, what will happen? Well, everything will work really fast. And then this server will be just trying to do its best. So what we can do is just add more servers. To do that, what we need is to use load balancing. So what we need to do now, I'm going to kill my instances. Well, kill, it's kind of violent. I'm going to delete them. There you go. And I'm going to go to Network Load Balancer. I'm going to say, OK, so I want to do load balancing. When you do load balancing, you have to do load balancing in a region. So you have to choose which one. In our case, we're using US Central 1. You have to choose the prefix. So there's going to be a lot of things that are going to be created for you automatically. So they're going to be all prefixed with ImageMagick here. I'm going to use ephemeral because they're still deleting. Yeah. So once if it was deleted, I could reuse ImageMagick, the IP that I created before. That could be the best solution. Still deleting, so I will leave it there. The port that I'm using is 8080. And create a new pool. Yeah, create it. And then there's the health check. And the health check, what it does is it actually pings the server. So it says every 5 seconds, it pings the server and it checks that everything is up. And you can see which instances are healthy and which ones are down. If an instance is down, the load balancer will stop sending traffic to that instance. And we're going to ping it on health check. OK, let's create it. The instances have been deleted now. And now what I will do is, OK, so you see there's a forwarding rule that has been created saying if there's any request going to that IP in US Central 1, redirect it to that image magic pool. What do we have in the image magic pool? Nothing. We don't have any instance yet. But I'm going to run, if I find it, there you go. I'm going to run new instance. And I'm going to run and say A, B, C, D, E, F, G, H, I, J, K, and so on. You get the idea. So I'm now creating all of those instances at the same time. I'm creating new disk, I'm creating new instances, I'm going to add them to that pool. So this is going to take a little bit. So I have source code to show you in the meanwhile. Let's go here. So what we do first, I'm using gcloud. And the good thing with gcloud is that it's really easy to write your own script using it. So that's exactly what I did. And the first part is, okay, create a new instance with a name that created based on the disk, on the snapshot image magic snapshot. Once you're done with that, I want you to create, so this is actually the equivalent to the form that we saw before. And by the way, at the bottom, you have a gcloud equivalent. So you click here and copy paste. That's very easy. And basically what I'm doing, the important part is that I also have a startup script. And the startup script, what it's doing is actually starting my server. So now when my image, when my instance starts, the first thing it will do, it will start running my server, which is exactly what we want. And then the last part is, OK, so now that the instance is up, add it to the image magic pool. So let's see if that finished. Our instances are running, and some of them have been already added to the pool. Cool. So let's see in here, our target pool. So they're all down. Why? Because they're still loading up, I hope. And very soon we'll be able to see how they start to become green progressively. So this takes some time. The image has to actually start the server and start replying to the health check. So now we have all these instances that started in around 2-3 minutes. So imagine you can actually run that you can do exactly the same thing with the REST API. So it could be really easy to write a little process that checks how many instances are pending, how many requests are pending. Oh, there's more than 10, spawn a new instance. There's not enough, there's too many instances, bring down an instance. And it's really simple. As you can see, it's just 3 lines of code, basically. OK, so I wanted to finish this talk basically letting you know that this is just a demo. And the goal of this demo is to help you use our cloud platform. To do that, we actually open sourced all the code that I showed today, and way more than that. And we want to keep on working with that. The next things that we're working on, it will be, we want to give you an idea on how to use managed VMs, which are now in beta. And I think that could make our lives, in this case, much easier. We want also to have an idea about deploying. We will also have an idea about how to do load testing, integration testing, and all the testings that we all love, and so on. So everything is going to be open sourced. It's already open sourced, and we'll send the link. We'll publish the link pretty soon, I guess maybe in the last talk of this track. So it's open source. So please help us. Thank you.